This is Neil Schneider for MTBS-TV at SIGGRAPH 2019. To my immediate right is Mikhail Mironov. He's software architect at AMD. And to his right is Frank Vitz. He's creative director of Immersive Technologies at Advanced Micro Devices. I hope I got that right. Did I get it right?
That sounds great.
Isn't that amazing? It took me 3 days to rehearse that, by the way. Now, what have we got on display here, Mikhail?
All right. We show two AMD technologies. The primary technology is AMD Pro Renderer. This is AMD ray tracing technology, and in this particular demo, we put it to the limit. We connected to wireless VR, so we want to try ray tracing inside wireless VR technology. So as you can see, this scene is ray traced, rendered on two AMD GPUs together, and we test in VR.
Amazing, amazing stuff. So when I actually tried it out, it was like a museum experience, and I was able to be like the director in this museum. Does that sound about right?
Yeah, this is the second demo. It's also two AMD GPUs, not ray tracing, but it's in VR. So what it is imitation of virtual director in museum. So you can shoot your videos in virtual environment, and at the same time, the video is rendered on the second GPU in high quality for future post-production. So you see what you're shooting. You don't use green screens. You are in VR. You are in this scene.
Okay, amazing. So yes, you're right. Like the first experience was like this chess game. I wasn't able to play the chess game, by the way. Because the pieces would have been too big for me. I would have been knocked out like a pawn if I played that chess game in virtual reality.
It's too busy with rendering, so there is not enough power to play the game.
Okay, good stuff. Now, Frank, it's a big honor that you're joining us. I mean, even before joining AMD, you're like a living legend in the film business. I mean, you did all the special effects with a number of X-Men movies and so on. You did Spider-Man. I mean, list goes on and on. But you're excited about immersive technology.
I'm excited to be at AMD because AMD has the new technology, the new hardware to power all the things that we've been talking about for so many years. And this stuff we're doing with wireless VR and ray tracing is kind of a confluence of the possibilities. These are, like Mikhail said, these are prototypes that we're showing today, but when we have people coming by with their applications for, in the energy sector or even retail, they see the possibilities of using the wireless VR with this fidelity of rendering. It makes it possible to do things that were very hard to do before.
As I indicated earlier, you've got a huge film background, even before joining the AMD team. If we were to look at the film industry, what are you excited about, like VR and immersive tech in the film business?
Well, yeah, there's this whole move by both Unity and Unreal into the virtual production space. We've done a lot of experimentation there. Now my group is providing a lot of the tools and components that make that possible. The real-time chroma keying, the virtual camera is really cool because what we're showing here with that museum piece is kind of like 2 layers deep. You're in a virtual world with a virtual camera looking at the virtual world. So that's very important for as a component for doing virtual production.
Good stuff.
And this is running in Unreal, by the way.
Exactly.
2 instances of Unreal.
Now, something new this year. Now, we've heard of ray tracing, but now we're starting to see ray tracing a lot more on the show floor. Right. Why is ray tracing such a big deal?
Because ray tracing gives much better quality, close to life quality to the picture. This is holy grail for every renderer buff. Everybody wants ray tracing. We are not there yet to play in ray tracing, but we are closing gaps.
Yeah, it's great because it provides the means to make really beautiful photorealistic images for purposes of feature film work where you want things to look real, but it also is physically accurate. So when you're doing pre-visualization for architecture or for a physical plant, the importance of it being accurate and correct, ray tracing solves both problems.
Another big feature, and I've seen this before as well, is streaming. Like you seem to be streaming this content to the headset versus being tethered. Can you elaborate a little more as to how this works?
So in short, we grab the frames from the game, we compress them with AMD hardware encoder and send them over regular Wi-Fi router, AC router that you have at home to the standalone headset. The headset itself was designed to run very simple games, but hell, we put small application on that and converted it to real untethered experience. And everybody loves it, because as soon as you need to walk around your models or jump or rotate and you don't have wires, everybody gets it. Pro business, gamers, everybody loves it.
Yeah, it's the best of both worlds in the sense that because it's wireless, you have the freedom of movement that Mikhail's talking about, but you've got the full power of an AMD GPU behind you on your desktop, rendering it for you, things that are hard to do in most, it's impossible to do today on the small processors on the wireless headset by itself.
So speaking from experience, I mean, in the film business, and let's say you're using virtual reality and immersive technology like this, how important is that mobility for a filmmaker when working with VR on set?
Well, I think it's critical because, time is money when you're on the set and you've got all these people, and the director wants to know that he's got the shot lined up properly. If he can just put on a headset, walk in there, take a look around and say, this is the shot that I want, boom, they move on. So that's just off the top of my head one of the first things. But you can use it also to build the sets. The artists can use them to see the angles, move things around dynamically. This is the start of a whole new wave of production improvements.
Good stuff.
Yeah. Imagine you are in a sound stage, huge empty space. You can walk around all this area and see your set. You can build a city and walk in the city.
Good stuff. Now, ProRender is the core to all this, I take it.
ProRender is core to certain demos. Not every rendering is using ProRender, but we are trying to move rendering technology, ray tracing technology as close as possible to VR.
And for those unfamiliar, what does ProRender do exactly? Like, what's its responsibility in all this?
It's implementing ray tracing algorithms. Send the rays, hit the objects, calculate shading, and give you accurate results, photorealistic results.
Excellent. Well, gentlemen, thank you both for joining us.
Our pleasure. Always a pleasure seeing you, Neil.
Okay.
Thank you.
This is Neil Schneider for MTBS-TV at SIGGRAPH 2019. Of course, we'll be back with more. Thank you for watching.